Hi, we're going to look at a typical investigation in first grade. Using two 10 frames, can you find three different ways to add 8 plus 7? Put 8 blocks in one 10 frame and 7 blocks in the other, and try to find creative ways that first graders might use to try to find the sum of these two numbers. Go ahead and pause the video right now while you try that and talk it through. If a group of students is successful at finding three different ways of adding 8 plus 7 or any other problem, I give them 3 marbles in their marble jar. And when the marble jar is full, we have a few minutes of extra recess. So that motivates. I'm going to show you a video of 2 students. Typically, I take videos of students who normally struggle in math, who show the thinking that actually goes on in a first grader who's trying to figure out base 10.
9 and 7. And then I need 16 because I can just go like this.
So this child sees 9 as almost 10. She knows that it's short 1, so she moves 1 from the 7 to the 10 to make 10, leaving 10, 6, 16. And the children often say 10, 6 as a mental bridge to 16. With time, she'll be able to visualize that movement. Given more time, she'll be able to say 9 plus 7, move 1, 10, 6. 9 plus 8, move 1, 10, 7. And that then transfers to numbers in the 20s or 30s or 40s. So this child saw 9 plus 7 as having a 7 that's almost 10. So she moved 3 from the 9 to get 10, 7 plus 3, leaving again 10, 6. It's not as efficient as the method used by the first child, but that doesn't matter. With time, she'll probably switch. The main thing is that right now, she's building 10. She's seeing base 10. Should be able to use that same strategy, adding numbers in the double digits. One of the problems that people run into when we use manipulatives is that it moves very slowly. The understanding of base 10 that is being built can take weeks or even months. This child struggled especially in first grade. By the middle of the year, we had gotten to adding to 20, numbers to 20, I believe it was December. And we had a game where there's a bag of 15 blocks. One person turns their back on the partner, takes some blocks out, leaves the rest in the bag, and then shows the partner what's been taken out. I was playing with Logan, so I took out 1, hid the rest in the bag, turned around, and showed him the 1, and he, of course, said 14. There were 15 in total. I did it again and took out 14, leaving 1 in the bag, and he knew that as well. Then I thought, oh, this child's understanding, and took out 7 and left 8 in the bag and turned around and showed him the 7. His eyes immediately teared up. I could see that he was struggling to try to remember the number pair to 15, had nothing to fall back on. He could not yet visualize the 15 as a whole 10 frame and 5 more. So I said, oh my gosh, I forgot the most important part of this game. We were supposed to draw a 20 frame. So I drew that 20 frame that you see on the picture there and colored in 15 of them. That's why it's rather messy looking. I put the 7 that from my hand onto the board, and he counted what was left. There were 8 blue shaded squares left unfilled with blocks, and so he counted them. 1, 2, 3. That's how many he counted in the 10 frame on the left. 4, 5, 6, 7, 8. That's how he counted the 5 on the right that were empty, showing that he understood that those 8 empty boxes represented the 8 blocks that were missing to make 15. I gave him a little nudge then, and I said, I wonder if there's a more efficient way to do it. If you look at the ones on the right, you can see that there's one column of them. And he said, oh yeah, that's 5. And I said, well, then let's start with the 5. So he said 5, pointing to that, and then he pointed to the 3 empty ones on the left and said 6, 7, 8. That makes 8. It was a couple more weeks before he could play this game confidently, before he could visualize that 10 frame and the 5 more, before he could visualize the 15, before he could visualize what's missing out of the 15, representing what's in that bag. But that was time well spent, because he would leave that with the visual understanding of how to make 10 or how to make 15, and that can be transferred to any 2-digit number. 27 plus what equals 35, for example, will represent no more problem, no algorithmic needs beyond what he already learned. So I'd like you to stop the video and reflect on that for just a moment before you start it up again. What does this look like for a first grade class? We start with the concrete, of course. 20 frames, 10 frames, 20 frames, 30 frames, 40 frames by the middle of the year, and lots of games. And there's a wealth of games in any Singapore math book, online, on Pinterest. Then we begin to use 20 frames where the dots are not movable, where the dots are photocopied right onto the problem. And the child has to put their fingers on any circle that they want to move. And for example, here they could take the top 2 on the right and pretend to move them to the 10 frame that has 8, seeing then that they're left with 10 and 5, 10, 5. Or they could move 2 from the right one, from the right column of the 10 frame on the right, and any method they like, but it is less concrete and therefore requires much greater powers of visualization. We then go to empty 20 frames on your desk or on the wall, where the children don't even see the blocks or the discs or anything else. All they can do is visualize in their minds, pretend that there are 8 blocks or discs on the left and 7 on the right, and there's 2 missing on the left, and I've got to move 2 into there. What have I got left? That visualization allows children to then move to the next step, which is mental math. And being able to do those calculations quickly in your head, barely even visualizing, almost skipping over the visualization, but it's there. We then go on to picking up pencils finally, and the children will explain their thinking in written terms. Well, I saw 8 and 7, so I broke the 8 up into 5 and 3 so that I could put 3 with the 7. That leaves me 5 where the 8 used to be, but the 7 turned into a 10, so I have 10, 5 equals 15. That's just one way that a child could explain their thinking on that problem. We usually start with the teacher writing out what the child's thinking is. The children aren't even using a pencil yet, and then the child writes this down themselves. After some time of concrete and pictorial, we will begin to use a place value chart. It is different from the 10 frames in its structure, but follows the same rules, that When we have too many ones, we have to regroup them into the tens column. 10 ones, give me 110. One of our teachers says that there's a place value police that says you can never have more than 9 in any one column. So every time you get more than 9, you take 10 of them and call it a 10. The children could do that. They must, however, do it with blocks first, then with drawings, finally with numbers. 15 ones is 10 too many. I better bundle up 10 of them and move them to the tens column. It's giving me 1 10 and 5 ones. 10, 5, 15. And the last step is that they write that in an equation. This is almost a footnote. This is almost a nod to the world of mathematics, where people write things out in shorthand. 8 plus 7 equals 15 is the tip of that pyramid that shows all this understanding that went on before it.